So, good morning, everyone. Not good morning, good afternoon, everyone. I am a little bit sick, and this lecture was supposed to be on campus, but unfortunately, I got infected last week, so I decided that I should be careful not infecting others in the class. So, probably next week I will do it live on campus. But this week I will have my lectures from my home. Welcome everyone again, and this is the first part of the course, that is the requirements engineering. And in this lecture, let me show the slides. So in this part of the course, we will have 3 lectures. So we will have 3 lectures. And in the first 2 lectures, we will talk more about theoretical aspects of requirements analysis and requirements specification. And then in the third lecture, we will work more using tools and do some hands-on sessions. The first 2 lectures will be as usual, like 2 hours or 1 hour 45 minutes maximum. But if you already noticed on time edit, the third lecture will be for 3 hours. So it's an exceptionally long lectures, but we will do it with breaks. But the plan is to cover as much as possible and as much as you need for your assignment. In the previous years, we had 4 lectures, but then to accommodate or to organize the course in a better way, now we are having 3 lectures for this part. Going back to my previous slides, so in this lecture we will use mainly this requirements engineering book by Ian Somerville. We cover many of the chapters from there, but you can also look other books like famous software engineering books or book by Somerville also. Then for the assignment part, so this week and next week will be our lecture week. So after February 1st, you will start working on your assignment. So next week and the following week will be your assignment period. So you will have your deadline on next Friday, that is February 11th. But I will come to this assignment more detailed on February 1st, that is our last lecture. So for this lecture, you will see that the slides are heavy, so they are rich in content, and the purpose is that you follow the slides as much as possible. That will eventually help you to prepare for the assignment. So the assignment will be mostly based on the lectures. And since these slides are prepared from the books, so if you wish, you can go through the books, but I guess these slides will be sufficient to prepare yourself for the assignment. If you have any questions, you can ask either on Slack in the proper channel, like in 01RE group. Don't put the questions like in a private message or in the general channel. Rather, put your questions in the more appropriate channel, that is 01RE on Slack. Additionally, you can also ask questions on YouTube comment box. So I'm basically following the both on my other screen. So I will cover, or I will not miss any question. In this lecture, we will cover several basic and some theoretical parts on requirements and requirements engineering. Firstly, we will talk about what do we mean by requirements and requirements engineering. Then one of the most critical part in requirements engineering is the requirements document. Then how can we elicit requirements, and how we can analyze and negotiate requirements. And last but not least, the fact that requirements should be described using clear language rather than ambiguous and non-clear language. So describing requirements properly is also important in requirements engineering. Let me see how many of you are following. Okay, I do not see how many people are following, but let's dive into the lecture. The first part. So what are requirements? Requirements are descriptions of how should behave. So here behave means what a system should do, and not only that, but also sometimes you can specify attributes or properties of a system. So basically requirements include two things. So what a system should do and under what condition it should do. Then requirements are usually defined in the early stages. This might not be always true today. It was the waterfall model that proposed requirements to be defined and clearly specified in the early stages based on which developers will work. But nowadays we have more agile methodologies that continuously improve or update requirements based on the changed customer satisfaction or expectations. So in general, requirements describe user level facility. So that this can be any functionality. For example, if a Microsoft Word or word processor wants a spell checking or correction mechanism, so this is one functionality. It can be very general system property. So it can be a very high level. For example, if you want to log into a system, you should have be authorized user before you actually start using the system. And this can be some constraint on the system. For example, if you have a sensor-based system, we might put or we might specify that each sensor will read the data from the environment like 10 times a second per second, or a specific number of seconds, a specific number of times per second. And there can be some development constraint also. So for example, some clients might have preferred only Java, or others might prefer JavaScript and so on. Just to mention here, I forgot to mention earlier that the slides are also on my Moodle, including the reading materials. So if you want to follow the slides, you can also follow them from there. I just put them, I think, last night. So ideally, requirements should be statements about what a system should do, under what conditions, but not how it should do it. So how it should do it should be concern of the developers or the designers, and not the users. And when we are talking about requirements, there are many concerned parties. So we will also discuss more about them later. Let me see if there is any question on the Slack. Not yet. So we discussed the general term of requirements, but there is more specific term or definition provided by IEEE. So IEEE is a standard, or is an organization that provides standards for many engineering disciplines. So software engineering is one of them, and they have a thorough dictionary for software engineering that defines hundreds or thousands of terms, software engineering terms, and the dictionary is known as IEEE Standard Glossary of Software Engineering Terminology. It's been continuously updated. But the one that was standardized or proposed first, it was in 1990. So they define software requirements as this. So software requirements are condition or capability demanded or needed by a user to solve a problem. So this problem can be from any domain or of any nature that can be solved by a software. And then software requirements are also conditions or capabilities that should be met as part of a contract, or basically software requirements are or software requirements document. They are a contract between the users or end users and the developers. So this can be seen also as a contract. So software requirements can be seen as a contract. Requirements can be seen as a statements, set of statements to solve a problem. But it doesn't finish here, because the third requirements, or not requirements there, third condition, or as the third part of the definition says that this contract or this capabilities of a system must be documented. So if they are not documented, they are not considered as requirements, because if you do not document requirements, they will get lost eventually. That means they will not be implemented and tested and so on. So documenting requirements is important also from the software development perspective. So we now know what is software requirements, but then there is another terminology, that is requirements engineering. So we have requirements, but how do we engineer it? So that is the main, basically, when we are talking about requirements analysis or requirements specification, that is meant by, or that is the ultimate goal of requirements engineering. So you basically come up with a set of statements from the stakeholders or the end users, and then you represent them in a way that is understandable by everyone, including technical and non-technical person. So requirements engineering, or we call this engineering when this is, or when any activities or any process is systematic and repeatable. So if we are if we specify a requirements using requirements engineering techniques, any developers or any testers who will read that requirements will understand it in the same way. That means any developers that who will implement that requirements will also implement it in the same way. So that is the key feature of any engineering discipline. So any action or any item that we are producing should be repeatable, and this repeated action should produce the same result. And that's how requirements engineering became known or introduced as part of, or similar to, other engineering discipline like mechanical or electrical or chemical and so on. So in general, requirements engineering is a process. So this process include defining, documenting, and maintaining requirements. So this definition was provided in a book by Bashar and Steve, and this was one of the very first definitions of requirements or requirements engineering. So the idea here is that requirements engineering is a process. It's not uh, an action, single action, or not a single job, but it's a combination of many things together. This I already mentioned in the waterfall model. Requirements were uh, uh, thought to be finalized in the first phase of the software development, but these days requirements are never finalized until they are delivered to the customers. But sometimes even the requirements might change after it is delivered. So in the agile methodologies or in the rational unified process, for example, requirements continuously change throughout their life cycle. But we talked about requirements and requirements engineering. And we also mentioned briefly about requirements document. So what is that? What is requirements document? So it's the official statement, or I also mentioned it's a contract between the end users and the developers. But formally, requirements document is an official document of the system requirements for customers, end users, and software developers. So whatever you are developing, whatever you are testing, if you want to upgrade a requirements, everything should start from this document. So we have to look at this document first, what is written something about a requirement, and then reflect on this requirement in the system side or in the development. There are many other names for requirements document, functional specification, requirements specification, or SRS, and so on. Also, as part of the assignment one or the RE assignment, you should also create a requirements document that I will explain more maybe in the third lecture. So types of requirements. Requirements can be, of course, on different types. There is not only statements that we read and we go for the implementation right away, but this classification of requirements, or not the classification, I would say the types of requirements can be done in from various perspectives. For example, based on the level of details. So usually requirements come from different stakeholders, right? So if the requirements are coming from, let's say, end users who might not be highly technical, their requirements are described using high-level language without technical details. So those we call them stakeholder requirements. And then there is also system requirements, and they usually come from the developers or testers or who will maintain the system. And they are usually more detailed and they have some more technical information within the requirements. And these system requirements can be also modeled or represented using different notations like data flow diagram, class diagram, object diagram, and so on. And then, so this is basically based on how detailed we are expressing our requirements. But then there is also another types of requirements, or we can group or classify requirements based on their goals. So some requirements fulfill our functional objectives. So those are known as functional requirements. And some requirements fulfill our uh, system properties or attributes, or in other words, how we want our system to behave. So those are non-functional requirements. I will give an example maybe in the next slide, but usually non-functional requirements or high-level non-functional requirements, they can be decomposed into functional requirements. So how we can do that? Let's say we have a requirement called a non-functional requirement, that is the authentication process should be completed in 10 seconds or less. So this is a high-level non-functional requirements, and this can be uh, like break down into multiple requirements. So the authentication process is a requirement. The authentication should be successful or completed. So that is another requirement. And then the authentication should be done in 10 seconds or less. So that is also another constraint or requirements. So this authentication process is clearly a functional requirement, and this state of the authentication that is completed or successful, plus it should be done in 10 seconds or less, they are constrained on these functional requirements. So in general, we can say that non-functional requirements are the combination of functional requirements and constraints. So when we add constraint or impose constraints on functional requirements, that become a high-level non-functional requirements. So I guess you got this clear, because also as part of the assignment, you will be eliciting requirements, or you will be providing statements for requirements. Make sure that when you are eliciting requirements, you do it in this proper way. Then that your requirements include both the functional part and the constraint part. So any questions so far based on the requirements that we discussed, or the concepts of requirements that we discussed? Okay, on Slack, I see no. And then on the YouTube, I don't see any questions either. So I can proceed. So until now, we were talking about requirements, but I also mentioned briefly about stakeholders. And important thing here is that the requirements are coming from stakeholders. So what do we mean by stakeholders? So stakeholders are not always the end users. There are an exhaustive list of stakeholders, and any people who are affected by the system directly or indirectly are parts of the system stakeholders, and they might have their own requirements that should be considered when you are creating your or eliciting your requirements. I will also come later what do we mean by requirements elicitation, but here let's talk about stakeholders. So stakeholders can be end users of the system, stakeholders can be managers, or any management people who are managing or running the organization. It can be engineers who are developing or testing or maintaining the system. It can also be the customers of the organization who will use the system. And there are also other external bodies or stakeholders, for example, who are regulating the system. It can be government, it can be local government, it can be any safety or security authorities that provides you safety certificates and so on. So here is an example. We want to develop an automated railway signaling system. So the question is, who are the stakeholders for this system? anybody wants to give any input in the chat or maybe on Slack. People who already have the slides, I think they know the answers or some of the answers, but maybe I would like to listen from you live. So anybody wants to put heads up? Railway owners. Yes, usually, I mean, the government is the railway owners, or the state or the country is the railway owners, right? But I mean, any maybe more specific stakeholders. Once someone said, let me show this in the chat. So someone said people who walk and drive around the tracks. Yes, someone said passengers. And yes, I think you are getting there. You are telling the right or exposing the right list. But the list is, yes, someone also said drivers. But yes, the list is exhaustive and there can be many more. And I can give some of the examples that you already mentioned. For example, operators who are responsible for running the system. Yes, also you yourself as who is traveling from Växjö to Stockholm, so passengers. Then the train crew, railway managers, people or engineers who will install the equipments. Also, yes, someone mentioned the manual signalers who will be replaced. So there can be many more, and all of these stakeholders might have their own requirements. If you are developing a system, let's say an overall system to manage your railway signaling, and you should not forget even a small stakeholder, because you might miss some critical requirements. So a good practice is that you need to draw up an explicit list of stakeholders. And this is also part of your assignment, will be part of your assignment. So I'm as you can see, I'm signaling those things that are part of your assignment so that you clearly know what you need to do and focus or put more attention on those. So this will be also part of your assignment. And what from the previous years I saw is that you do not come up with explicit list of stakeholders. You only think about most 2 or 3 or 4 or 5 important stakeholders and you ignore others. So your stakeholders list should be explicit, exhaustive, and as many as possible there should be. So we talked about requirements, we talked about requirements engineering, we talked about requirements document, then we also talked about stakeholders. Then there is another concept, that is requirements engineering process. There can be also a question in your mind that what is requirements engineering and what is requirements engineering process, or what is the difference between requirements engineering and requirements engineering process. So requirements engineering is a set of activities. So there is a definition of the requirements, there is specification of the requirements, there is analysis or negotiation of the requirements, and so on. But requirements engineering process also include those activities, but in a more structured way. in an ordered way. So when you are defining a requirements engineering process, or you are following a requirements engineering process, you cannot pick and choose any activities from your list of activities. So if you should pick basically it's a well-defined process in which you should start from one point and follow the defined process in a systematic way or in a structured way. So when you do this, your requirements engineering becomes a requirements engineering process. It can vary uh, across the organization, even across the department, and there is no best engineering process. You can adapt or change your requirements engineering process over time if you think that your process is not doing best, or your process is slowing down your development, or your process is increasing your budget, and so on. So there is many opportunities to improve your requirements engineering process, and that's why there is no best requirements engineering process either. So all of them I mentioned, I think I will also discuss briefly later, but a requirements engineering process or a complete process should include these following things as part of your process. What are those things? That is, what activities will be carried out as part of your requirements engineering. It can be specification, definition, analysis, negotiation, and so on. The schedule or the structure of these activities. So for each of those activities, you should have an estimated timeline, and then who is responsible for each of those activities, the inputs and outputs of those activities, and what are the tools that you will be using to support or perform those activities. So as you can see, requirements engineering does not mention these items, but when you are following a requirements engineering process, you have to include these items in your as part of your process. In general, very few organization tends to follow this or have any requirements engineering process. Rather, they are more inclined or more interested to have the final outcome of this requirements engineering process, and that is the requirements document. So companies or organizations think that whenever they have this requirements document, they are done with the requirements analysis, and they start the development or testing right away. But uh, it it has many risks on the development itself. So if you have a good requirements engineering process, that will also make sure that we will have a good requirements document, because this requirements document is the ultimate outcome. So if your process is not good enough, your outcome might not be good enough too. So you should be careful. Uh, Let me see if I have any questions so far. Not so much. Let me progress. So this shows a spiral view of the requirements engineering process. So as I mentioned earlier, a requirements engineering process include these items, but this gives a more clear picture graphically. And by the way, this figure is also from the book, so you can find more details about the figure. But when we are talking about requirements engineering process, it involves mainly three activities or three different, it has main three focuses. So one is the requirements specification, another one is the requirements validation, and also the requirements elicitation. Actually, we start with the requirements elicitation, and then we go for the specification, and then we go for the validation. And the outcome of the requirements engineering process, as you can see, is a requirements document or system requirements document. Now, coming into the closer of the picture, we can see that we starts from requirements elicitation. So we starts here, and then we have some business requirements. So those business requirements are high level requirements. Let's say if we have a e-commerce site, our business requirements is like we want to sell as much as possible. We want to do some promotions. We want to give some discounts. We want to increase the revenue. We want to target certain user groups and so on. So this is the business requirements. And once you are done with this business requirements specification, you need to, so we are in the specification phase now. We need to validate those business requirements. So we are doing the feasibility study. That means we will check if those business goals are feasible or possible or not. If they are feasible, we go back, we continue. So now we are in the requirements elicitation phase again, where we are eliciting user requirements. So here users are basically end users or even other stakeholders. And once we elicit the requirements or user requirements, we go to the next phase. So we specify them more formally. And once we specify them, we need to validate them, right? So one of the way to validate those requirements is to develop a prototype or a draft version of the application. It can be using any language or in any other form. It can be even using pen and paper. So this is one way of validating your requirements. And once you, let's say, draw your system on pen and paper and present to your end users and they accept it, now you go for the system requirements elicitation. So you are opening up your requirements, and from user requirements, now you are going to system requirements to specify more detail about requirements at the technical level. Okay, so there is a question here that says, what is the difference between eliciting and specifying? So when you are eliciting a requirements, so you are eliciting requirements from the user, right? You are eliciting the requirements from the developers or testers. Those are system requirements elicitation. So you are eliciting them, let's say, in a high-level language, the way they explain you, the way they tell you the requirements. But this elicitation or these requirements might have ambiguity. They might have overlapping. They might have unclear statements, and they might have any other gaps in the statements themselves. But when you are specifying requirements, you are basically identifying those problems and making sure. There are many techniques for specifying requirements, like mathematically, graphically, or even using natural language. So when you are specifying your requirements, you are eliminating those problems that are in the requirements elicitation. So the requirements that are in the elicitation phase, they are same in the specification phase, but they are expressed using different forms, or maybe they are improved to eliminate those ambiguity or those or add some further clarification and so on. I guess I could answer your question. And then there was another comment or maybe question: is eliciting more about bringing ideas? Is eliciting more about bringing ideas forth and specifying about clarifying them, especially for a I was not sure what you wanted to know, but yes, eliciting is more about introducing ideas or requirements, and specifying is more about present the requirements to the developers or to the technical people in a way that it's non-ambiguous, it's clear. But yes, I guess I got your question. I could answer this. Okay. So once we have the system requirements that are elicited, again we are going for modeling of the system requirements, and at this point, basically you use different diagrams. It can be deployment diagram, object diagram, class diagram, data flow diagram, whatever modeling tools or language you can use. And from there, to validate those diagrams, basically you review your requirements, and this review include the discussion of the requirements and identifying any further gaps or clarification issues in the requirements before you develop your final requirements document. Because once you are finished with developing your requirements document, it's very hard, not only hard, it's very expensive to go back and modify your requirements, because many stakeholders are involved in the requirements elicitation. So you might not get all your stakeholders whenever you want, and especially when you are done with your requirements document. So it's better to continue your process, and that's why requirements engineering process is also a continuous process, and it's better to view in this spiral form, because you continue your elicitation, specification, and validation unless you are happy with your until you are happy with your requirements document. So what if that there is a problem in your requirements engineering process? Of course, you need to identify them, those problems, but there is two way basically to identify those problems in your process. One is through the process itself, or through the information about the process, and another one is through the information on the product. The second one is a bit late, or I'd say too late, and it's more expensive to identify problems in the process. So try to find out problems in your process as early as possible. But there is a way that you can, like more systematic way that you can use to identify problems in your requirements engineering process. And that is, you ask a set of questions to yourself, or as a manager to your employees, or as a stakeholders to other stakeholders. And what is that, or what are those, is that as a manager, are your requirements engineering process cause you usually over budget, and you most of the time takes take longer time that you need to deliver the software or product? If you answer yes to this, that means your engineering process has a problem. And then, do the developers or people involved in requirements engineering complain that they do not understand, or they do not have enough time, or they do not have even enough or appropriate tools to work on the requirements? If they say yes, that means your process also have a problem. Remember that in your requirements engineering process, you not only need to specify activities, but also you need to specify peoples and tools that will be part of those activities. And then, are there any understandability problems or completeness problems in your requirements document? If yes, that means your requirements engineering process has problem. Do you sometimes need to do rework for some of the development works or testing works or even requirements specification part? If yes, that means your requirements engineering has a problem. Sometimes your requirements engineering process might miss some of the requirements to be implemented or tested, and as a result your end users might not get all the requirements it want as part of the system capabilities. So if this is the case, that means your requirements engineering has a problem, or requirements engineering process has a problem. And then if your systems are receiving high change requests, that means you developed and delivered the system, and then the users might not be completely happy, and they are asking too many changes. That means your requirements engineering process has a problem, and that means your requirements document was not well developed. And sometimes in the meetings with the stakeholders, or in the departmental meetings within the organization with the developers and testers, it might be the case that they or the participants in the meetings do not agree on a certain thing, and they continue the discussion. That means your requirements engineering process also have problem. So if you answer yes to any of those questions, that means your requirements engineering process has a problem. But what if you answer no to all of the above questions? As I mentioned earlier, that even if you don't have any problems with all these things, you cannot claim that your requirements engineering process is perfect or best. It could be natural or by chance, but it's also possible that yes, you answer no to all of these questions, and you are still delivering a bad product, or you are still your end users or customers are still not happy with your product. So there is no one good requirements engineering process. It differs with the organization. It changes over the time. And then when we talk about requirements engineering process, most of the requirements engineering process primarily concern with the output. I think, as I also mentioned it earlier, that they focus more on the requirements document rather than the process itself. So there is no well-defined requirements engineering process document either, or standards either, because since it's vary according to the organizational needs. But United States Department of Defense had a standard that was 2167 for their requirements engineering. That is also considered one of the widely known and one of the very first requirements engineering process document, basically. But still, those were in the military software or hardware engineering processes. Those might not be applicable for small scale regular software engineering projects. So we expect a good requirements engineering process to include these three activities. That's the requirements elicitation, then requirements analysis and negotiation, and requirement validation. And these three activities were basically shown in the spiral model that I showed here in the earlier figure. So it is in this figure. So this is one of the standard or widely followed requirements engineering process. You elicit your requirements, you analyze and negotiate your requirements, that is basically requirements specification, where you eliminate ambiguity, you eliminate gaps, you clarify, and then you do the requirements validation. So coming back to our previous slide, so these three activities are basically core activities in the requirements or good requirements engineering process. And now we will talk about requirements document. We already mentioned something about requirements document, that is the official statements, and there are many names for the requirements document. But good requirements document, so what do we mean by good requirements document? So good requirements document, they are clear and consistent. That means it's easy to read and understand, not only by the system developers or testers, but by a range of different readers. That means all the stakeholders. Any stakeholders who is part of your system should read this document and understand your requirements. And you should be also be concise as possible, as concise as possible, because you are not writing a book or you are not writing a story. So your requirements or your system requirements should be very concise, at the same time understandable and consistent. Practically, this is very hard to come up with a good quality requirements document, because there are many stakeholders, they have different skills, different technical knowledge, and as a requirements engineer, when you are trying to balance everything, or you are trying to balance between the or among the stakeholders and their understanding level, it's hard. But try to follow this guide, these three principles, but then you can have a good quality requirements document. So be consistent, make it easy to read, and be concise as possible, as much as possible. There is many, I would not say many, but there are multiple standards for requirements document, and it vary also according to the organization or practice, and how different companies define their requirements. But a good thing about a good and easily understandable requirements document is that readers are able to find information very easily and quickly, and sometimes we might have requirements that are related to each other, right? So by reading your requirements document, it should be clear for the readers also the relationship between different parts of the document. There are other benefits also for a good requirements document. For example, it works as a checklist. So if you have a standard, you can follow that standard, and this standard works as a checklist when you are writing your requirements documents. I think I have an example in the next slide, maybe, or in the next couple of slides, how a standard document, a standard requirements document looks like. And then reviewers can also follow that document structure or standard document structure to review the document. So they can basically have a clear picture in their mind what they are expecting in your requirements document if you have a clearly defined standard structure for your organization. So one of the most common or standard requirements document in terms of structure or what will be in your requirements document is defined by this IEEE 830.193 standard. And I think, yeah, this is the standard, or let's say a structure uh, that should be followed by a good requirements document. So as you can see, it has 5 parts. In the first part is the introduction part, where you briefly introduce your uh, objective, you define various terms and acronyms, you give an overview of your document, so the remaining part of your document and so on. In the second part, you mostly focus on the products. So what are the product functions? So basically those are high level user requirements. Your user characteristics, so mostly about your stakeholders, and some constraints, and if you have any assumptions and so on. So those general constraints are, they can be development constraints or constraints about the system also. And the most important part of the requirements document is the third section, where you specify your functional and non-functional requirements and also interface requirements. And at this point, you can also mention about database constraints, design constraints, or any other system attributes you want for the system. And the 4 and 5 sections, they are mostly appendix and index. Those are optional, but this section 1, 2, and 3 are mandatory for any requirements document. I think there was a question that I missed. So it should not contain technical language, since some stakeholders are not technical. I might miss for which part of the lecture this question was, but yes, the requirements document, since you know that they might have user requirements, they might have system requirements and so on, you might organize your requirements document in a way that some part could be useful for non-technical people. Let's say when you are talking about product functions, or you are talking about general constraints, but some parts could be dedicated to technical people. So in section 3, you are basically going detailed about technical constraints, or you are focusing technical aspects here for your requirements, rather than in the general description section. I guess I could answer your question. So as you can see, you have general section and specific requirements. So general section could be, for example, more useful for non-technical stakeholders, and this section 3 could be useful for technical people or technical stakeholders. I think I have a couple of slides before I go for a break and give you also a little break. That is best practices for writing requirements document. These are very common practices that are also applicable for general documents. For example, white margins, using tables and bullets and numbers lists instead of large, long, boring paragraphs. Uh, uh, Separate the equations from the text, not putting any equations in the text. Having or using diagrams to describe a process, rather than describe the process in a paragraph, long paragraph, and not using complex diagrams. So these are common practices for requirements document. But then there is other criteria for which your requirements document should be easy to modify or change. That is, uh, try to write your documents in a loose leaf binders. That means it's easy to change any part without breaking the whole document. So, and also, if you are, let's say, starting a section or chapter in the middle of the page, and in that page something changed, basically you need to replace that page, which is for both the previous section and the new section, right? But if you start your each chapter or section in a new page, you simply ignore that page without affecting other chapters. So these are principles for loose leaf binders. Also, uh, carefully choose your page numbers, that you don't miss any page numbers. Make sure that all your figures or tables are labeled. Keep your chapters short. You keep your paragraphs short. And then if you are using numbers, let's say for figures or tables, make sure that you relate them with your chapter. For example, if you have two figures in chapter 1, they should be figure 1.1 and 1.2, and similar for tables and so on. Yeah, these are, very general requirements also for other documents that you want to make easy to read or easy to change. So I think there is nothing new in terms of requirements document. Now, the target audience of the requirements or the users of the requirements document, who are they? First of all, the system customers, so the end users, they specify the requirements using high-level language, and they are the ultimate users of your system. Then the managers, who use requirements document to plan the resources and times, so they are also important uh, stakeholder for the requirements document. Then system engineers, who are basically developing and testing your requirements. So if your requirements document is ambiguous, not clear, not easy to follow, that will make their life very difficult. Then maintenance engineers, once the system engineers developed and tested the system and it's delivered, then the ball is with the system maintenance engineers, because they are monitoring the system, they are following up with user changes or change in requirements and so on. So they should be also part of the requirements document, and their concern should be also be met by the document. System test engineers, so they are also doing the testing. So in terms of integration testing, user acceptance testing, and so on. So all kinds of test engineers should also be able to easily read and understand your requirements document. I think that was the first part of the lecture. The second part is more smaller. So let's come back in 10 minutes for a quick break, and we will continue with the second phase of the lecture, that is requirements elicitation. So see you in 10 minutes. So we will start in a few seconds. Yeah, I think we can start since it's 2:30. And yeah, the second part for this lecture will be about how we do the elicitation and how we can analyze and describe requirements. So what do we mean by requirements elicitation? Um, we are talking about elicitation for a long time now. And the primary goal of requirements elicitation is to discover all possible requirements for a system. And this should be done in collaboration with or in communication with all the stakeholders. So the like customers, managers, system users, developers, and so on. In order to do the requirements elicitation, um, you need the application domain knowledge and also the organizational knowledge, and most importantly, the problem knowledge. So let's say we are developing a website for an e-commerce system. We should know how e-commerce business run. And maybe I can ask a little question here. So we are talking about requirements elicitation, but who is responsible or doing this requirements elicitation? Any idea from your side? I think it's 2 seconds uh, behind the live, so I have started receiving responses now. So someone said PM. I guess it was meant by product manager, uh, project manager. That is. Any other thoughts from others? Not much. Yes, it depends on who is playing which role. But if the project manager is also playing the role of requirements analyst or requirements engineer, he definitely can do that. But primarily, requirements elicitation is the job of requirements analyst or requirements engineers. Uh, Another, someone mentioned designer of the system. And designers, I mean, they have different roles, of course, as you mentioned, to design rather than playing with the requirements. So they are more in between the requirements analysis and the development. Uh, Someone was asking an interesting question: if is there any such position as requirements engineer? Yes, in the large projects where you have hundreds of requirements, you need to systematically manage them or organize them. You have positions for system requirements engineer, but they are often known as uh, requirements analyst or business analyst and so on. I mean, under different titles. So, but there are positions uh, for requirements engineers. Another comment, designer uses requirements document to design. Yes, I agree. So as to elicit requirements, basically you need domain knowledge, organizational knowledge, and the problem knowledge. So it's better to for someone who is working inside the company rather than who is working on behalf of users or customers and who has organizational knowledge also. So you to elicit the requirements or system requirements, basically you need to understand the problem. You need to understand the business process of the in the target organization, and also the application domain. So you need a complete picture, and without a complete picture, you might only grab or collect requirements from the stakeholders, but it will be hard to organize them uh, to better group them or classify the requirements. So I think I have some slides after on this. And then in order to elicit the requirements, you are eliciting the requirements from the stakeholders, right? So the first step should be identify the stakeholders themselves. And we already mentioned that stakeholders are anyone who directly or indirectly benefit from the requirements. And as a first step, the benefits of identifying stakeholders is that you most likely will miss any critical requirements, because if you miss any important stakeholders, you will definitely miss their requirements. You can discover different viewpoints of the for structuring the system requirements. So once you have requirements, different stakeholders might have their own views, right? So how they see the system, and based on their views or viewpoints, you can model your system requirements using different notations. And then if you are identifying all exhaustive stakeholders and discuss them with the requirements, then the stakeholders will feel that they are also part of the process, and they will not feel that they are left alone or they are not part of the system itself. So how we can identify the exhaustive list of stakeholders? First of all, the potential end users. From the business process, so we have a business process, right? Let's say we want to develop a e-commerce website. Obviously there is a company behind it who owns this e-commerce platform, and they have their own business process. So you should also know their business process in order to elicit or identify stakeholders, and then go to those stakeholders from that business process to elicit their requirements. So basically you should identify all the people who are part of the business process in the organization for which we are developing this system, this e-commerce system, let's say. And also the management people, they are part of the stakeholders, and the customers of the organization. So let's say Amazon have their website, Amazon has a business process, Amazon has also some management people who are managing Amazon, and as a customers of the Amazon, there are many people who are selling their products, right? And then as end users, we are buying those products. So those customers might have their requirements as part of Amazon, and we should also consider them. So end users and customers are not the same concept here. And people, of course, who are developing and maintaining the system. And other regulatory bodies or certification authorities. I think we already mentioned this exhaustive list, but I'm just mentioning which group you should reach to identify stakeholders. So these are different groups. End users group, people who are involved in the business process, people from the management group, the customer group, the development group, and regulatory bodies or other external groups. If you want to elicit requirements, one of the steps or activities that you should do also is define the environment, like where your system or software will be operating or running. And for that one, you need to know the configuration of the host computers. You need to know what are the hardwares and software your system will be interacting with, and so on. And the benefits of identifying this operating environment is also that when you are done with the development and you need to deploy this system, right? So you can foresee some of the installation problems, and you can thus design your system to avoid, for example, unexpected interactions with other third parties. And also, if you define your operating environments early, that means you can get system requirements that are more about the more on the technical level or more with technical details. And once you also define your environment, you can know that if your system or your software, uh, I mean, if you know that which software or hardware your system is communicating or talking to, you know also the compatibility requirements for your system with other external systems or other external software and hardware. So there are some benefits, of course, of defining operating environment, but the first goal is that you need to elicit system requirements. So for that one, you need to define your operating environment also. I just mentioned, like, those operating environment might include platform information, so libraries, versions of the libraries, operating system, and so on. And then also interface information. So if you are talking to third-party systems, like it can be any database on the cloud, it can be any other services or APIs. So you need to know those interfaces or what type of communication you need as part of your, or to operate your system when it's developed or delivered. And also there can be some software dependencies. For example, in Facebook, I can download my personal information in CSV format or any other format. So there is a dependency between spreadsheet and Facebook. And if you do not have Microsoft Office or any other programs installed on your system, you might not be able to look at those information. So there are like software dependency. So if you know in which environment you will be operating and what type of software dependencies or interface you will need, or what type of platform your system will run on, it's good for you to come up with a exhaustive list of requirements. So this is also part of the requirements elicitation. So one of the approach for requirements elicitation is to define scenarios. So scenarios are simply stories, and the goal here is to see. So it's basically a use case. So a interaction between your system and with an end user. So what input the end user is giving, what is happening behind, and what's the output that a scenario or a story produce. So this can be one way of eliciting requirements, and this is also this can be also done using pen and paper. You don't need to develop any prototype. to create these scenarios or to create these stories. So in the information in the stories or scenarios that are crucial include the state of the system before and after the interaction, the flow of the event, so what will happen with each input data, any exceptions that might happen due to some normal or abnormal input, information from other activities, like if there are any parallel activities that are going on, and also description of the system after the story or the scenario is completed. So also from these informations, you can come up with new requirements, and this can be helpful also when like you do not miss basically some requirements if you, or you will miss some requirements if you do not know what is going on within the system or inside the system. So stories or scenarios are those useful for those cases where you simulate small scale flow or workflow, and you know the input and output for each of the flows. Usually the scenarios or stories can be big, but there should not be, so each scenario or stories should not be that large, so maximum 3 to 4 page, but there should be more graphical rather than textual, so it's easy to follow and not boring for the readers. So the next is, so once you elicit the requirements, so let's say you have a list of user requirements, you have list of system requirements from your operating environment. Based on your operating environment, you also have list of requirements from the scenarios or stories. So these scenarios and stories can be also discussed verbally with your stakeholders rather than doing in pen and paper. So once you have these elicited requirements, the next step is to analyze requirements and negotiate with stakeholders. And there are multiple steps also for requirements elicitation and analysis. So you start from here. As a requirements analyst or requirements engineer, you should have a domain understanding. Then once you have the domain understanding, you go for the requirements collection. And once you collect the requirements, you go for the classification. But if you see that there are some missing requirements, you basically have, that means you have some problem in requirements in the domain understanding. So you have to go back to previous step. But if your requirements collection is done, you go for the classification. And again, during the classification, if you find that there are problems in the classification, that means your requirements collection was not done properly, so you go back. But if your classification is done well, now you go for conflict resolution. So conflict between requirements, conflict between stakeholders, and so on. And again, if you are not able to resolve the conflicts between the requirements or between the stakeholders, that means you might have problem in the classification, you might have problem in the requirements collection. So you go back. And once you resolve all the conflicts, your job is to prioritize the requirements. So to pick or choose which requirements will be implemented or delivered in this release. And again, similarly, if you find problems in prioritizing the requirements, you basically go back to the previous steps. Or if you do not have any problems and you clearly identify which requirements will be implemented, you go for requirements checking, requirements specification, and finally you create a requirements document. But again, similarly, if you have problems in the requirements checking phase or requirement specification phase, you do not go back to the previous steps here. As you can see, you do not go back to prioritization steps, rather than you go back to the domain understanding steps, because if you have problems in the requirements specification phase or in the requirements analysis phase, that means you do not have problems in the prioritization, rather than you have problems in the domain understanding. So you go back, or you start from the beginning, basically. And once you solve all the issues, like you could properly prioritize requirements, you could properly analyze and specify requirements, you basically create these requirements documents. So that's the process for creating the requirements document. Then once we create the requirements document, basically we are closed, or we are done with the requirements analysis. Now it's the time for implementation and delivery. But we might need to negotiate or analyze requirements before we produce the requirements documents. In other words, we need to agree on the set of requirements that are complete and consistent and not ambiguous before we create a requirements document. And when we are analyzing requirements and also we are negotiating requirements with the stakeholders, we might have different outcomes or states that we reach. For example, we might have missing requirements from some of the stakeholders. So what we do, we add the missing requirements. If we have unrealistic requirements that we found based on our requirements analysis and negotiation, we remove them. Same for the conflicting requirements, we remove it. And for the overlapping requirements or ambiguous requirements, we modify them to make them more clear, and so that they are independent, so they are not overlapping with other requirements. So this is part of the requirements analysis phase. But this can be viewed in another way. And we are spending more time on requirements analysis and negotiation, because once we created a requirements document, or once we develop the requirements, it's more expensive and time consuming than if we already clarify or make our requirements clear before we write the requirements document. So there is here is another view for the requirements analysis and negotiation. So we start with the requirements elicitation, right? So we start from this point, and then we have the first, in this point, we have the first draft of the requirements, and then we analyze the requirements based on the first draft. And we are at this point, we identify the requirements problems. And then once we identify the problems, we negotiate the requirements, and we have the first draft of the requirements document. So we continue in this way. We again improve our draft. We perform further analysis. We identify further problems. We do more negotiation. And once we continue, at some point, we will have a final requirements document, let's say at this point, or maybe in the next iteration. So from this figure, these lines in the spiral, they are known as activity, and these arrows, they are outcome. So in this figure, as you can see, we have 3 critical points, and those critical points are marked in red. So in these 3 critical points, we have the most problems and least stable requirements document, and they are more closer to the center. But the more away we go from the center, we get less problems and more stable requirements document. So that comes naturally if we follow a spiral process for requirements analysis and negotiation. Our aim, of course, will be eliminating problems as early as possible and as much as possible so that we have a good quality requirements document. And since we are talking about requirements analysis, there is a systematic way of requirements analysis. So when we call it systematic, that means we individually assess each requirement based on some criteria. And I would like to also emphasize on this slide, because this is also one of the slides that you will be using for your assignment, and many people either misunderstand or misuse this slide. And the reason is that we have 7 or 8 question here for requirements analysis. That means for each individual requirement, you will ask this question and you have some answers based on which you may decide that your requirements are complete and consistent or not. So the reason I was saying that people misunderstand or misuse this slide is that let's say we have 5 requirements. So they can be either functional or non-functional. So let's say we have 5 functional and 5 non-functional requirements, and we have 8 questions. So you should come up with a matrix with those 5 plus 5. So with those 10 requirements and this 8 question, and in that matrix, you should basically answer the question that are applicable to each of the requirements. I don't know if I could make it clear. So let's say you have a table. In the row of the table, you have these 8 criteria, and in the column of the table, you will have all the requirements. So for each requirement, you will basically ask this question and either say yes or no, or other responses, based on which you will analyze your requirements at the end. For example, the premature design. Does your requirement include concepts on premature design or implementation? If yes, you say you put a tick mark on, you say yes. And then combined requirements. So if your does this requirement is a combined one, like can it be broken down into several requirements? If it's yes, you put a tick mark, and then in your analysis phase, you say that, okay, these requirements can be broken down into several requirements. Thus, requirements X or requirements Y can be stated as requirements Z and requirements W, let's say. So basically, not only you have to use this table or matrix to identify yes or no, or to accept or reject this question, but also you need to do some clarifications or justifications. For example, if you find that one requirement is a combined requirements and that can be broken down into several requirements, you should do a clarification after that. I broke down this requirement A into requirements B and requirements C. And this is the same for other criteria or for the full checklist. So for example, if your requirements testability, that is the last criteria, is your requirements testable? That means you found that your requirements is testable. You put a tick mark on that call on that cell, and then if you don't find that your requirements is testable, you should take a note after the table or after the matrix and say why your requirements is not testable and what you can do or how you can revise your requirements to make it testable. Could I make it clear how you can use this checklist for requirements analysis? There will be some tutoring next week. I will publish the date also for tutoring. So if you have any question, you can join that tutoring and then ask if you have any confusions regarding this checklist or any other lecture material. And since I mentioned that some of the slides will be part of your assignment, so for example, this one, so understanding them well is also important. So basically what you do, you ask these 8 questions for each of your requirements, and if it's yes or no, then depending on yes and no, you should either revise your requirements or break down your requirements or whatever. So conflicts and the resolution. Again, when we are doing the requirements analysis, there might be some natural conflicts or overlap or missing information in the requirements, and this can be resolved using requirements negotiation meetings. So in those requirements negotiation meetings, it's good to include all the stakeholders, regardless of their technical knowledge. I think there was a question, is that, so basically not just answer yes or no, but to justify why no and how it can be improved. Yeah, not, I think there was a typo. So how it can be improved, not how it can't be improved. Yes, that was right. So in the negotiation phase, we basically should have meeting with stakeholders to resolve our conflicts, overlaps, and omissions in the requirements. And the benefit is that if you identify issues in the requirements early in the process, it reduces your time later, and also it saves your time in the later phases. Let's say in the maintenance phase, or let's say the developer has developed the component or the requirement, but then the developer identified that there was a ambiguity in the requirements or some missing information while he's writing code. That means the developer is writing code and the requirements document is already prepared. So now we have to go back to the requirements analysis phase and modify your requirements document. But remember that not only one developer is working on the requirements at a time. There can be multiple developers, multiple testers who are working using that requirements document. So if you don't identify the problems in the earlier phase, it's basically create problems for many people, not only for one developer or two developer. So if you identify those conflicts and overlaps and missing requirements early in the phase, it will reduce your time, it will save your budget, and so on. I did not, I could not relate this question to which content, how it can and cannot both equally relevant. I think, there was a misunderstanding. Then there was another comment. I think the focus is to identify the issues on the table and then elaborate below to use as notes when improving in the next iteration. Yes, I agree with Atakan. So that's the idea here. So using that analysis checklist, you identify problems, and then based on your response or based on your identified problems, you revise your requirements, and the requirements might not be same before and after the checklist. So coming back to requirements analysis, so in the requirements analysis phase or negotiation phase, we have three stages. So the information stage, discussion stage, and resolution stage. So those are pretty simple and straightforward. So in the information stage, basically you deliver or you present the requirements to the audience. So audience here is the stakeholders. Then in the discussion stage, the stakeholders discuss the requirements. And in the resolution stage, after some discussion, there need to be some agreement on the actions to be taken. So those agreement are, I think I mentioned in the previous slides. So the stakeholders will agree what will be the action for these outcomes. Either will we add new requirements, will we remove a requirement, or will we modify existing requirements. I think there is some comment or some text in the chat that are not recognizable. If you put subscribers only chat on the lives, you don't get scam links from bots in the chat. Okay, yeah, I think we should mark this down beforehand next time. Coming back to my previous slide. So for the negotiation phase, I mean, for the negotiation steps, we have these three steps: information, discussion, and resolution. And then once we analyze the requirement, now we are pretty close to the requirements document. So if you remember this slide, this spiral view, we are not this one. So if you remember this process, we are here now in the prioritization. So we resolved our conflicts. Now we are prioritizing our requirements, and in prioritizing the requirements, I'm just going back and forth. So prioritizing requirements mean giving some importance, value, or label to the requirements. Usually high priority requirements are implemented earlier and delivered earlier than low priority requirements. But then also it should be defined with the discussions among the requirements analysts and the stakeholders. And this is another way of resolving design conflicts or conflicts between the stakeholders. Usually, requirements can be tagged using numerical values, but sometimes it's hard to judge if you are using numeric scale. Rather than it's more useful if you use some categorical values, like if it's essential requirements, useful requirements, or desirable requirements. So essential requirements must be implemented. Useful requirements will be good for the systems, but the system can still run without those. but then the desirable are not necessarily uh, important for the functionality of the system, but it can make the system more attractive, let's say, or more presentable. So those are kind of optional requirements. So you can tag your requirements using this kind of classifications. And talking about classifications, it's also good to classify requirements. Requirements can be classified according to different criteria. And the benefits of classifying requirements is that you can group requirements based on commonalities or based on relationships between the requirements. And not only that, it's also easy to trace the requirements in the requirements document. And if you classify requirements properly, it might help you eventually to identify some of the missing requirements also. So for example, a common approach for classifying the requirements is faceted approach, where you identify a number of dimensions. So let's say one group of requirements could be about system, one groups of requirements could be about user interface, one groups of requirements could be about database, and one groups of requirements could be about communication. So after identifying those groups or terms, what you should do basically find which requirement fits best to which group, and also in that way multiple requirements can fit in the same group and vice versa. That is, one requirements might fit to multiple groups. So in that way, basically you can find commonalities or overlapping or relationship between requirements. I think I have an example here. So for example, a graphical user interface to the account data should be provided. What are the possible classification? I think there was a question that we already discussed. If you conclude that a requirement is unrealistic, you should likely remove or modify it, right? In the first place, we should try to modify it to make it realistic. And if it's unrealistic totally, then we should consider remove it. That's my thought. Yes, this is also a good classification technique, Moscow, as one of the participants mentioned. But you can use any classification technique for your requirements. As far as I remember, there is also a requirement for the assignment that you need to classify your requirements. Pick any one and do your classification. So here was an example. A graphical user interface to the account data should be provided. So what are the possible classifications? I think we are also running out of time, so I will not wait for your, or I will not ask for your input. Rather than I will provide my answer directly. So this can be classified under user interface group, under database group, and under security group. So you can basically maybe find out more groups and then put this requirement or tag this requirement using each of those classification items. We should also do or assess the requirements risk. And good thing about assessing requirements risk is that they may help you to avoid future problems in the development and testing. And if you find out some risk in your requirements, you should try to mitigate those risks either by modifying the requirements, or let's say to ignore the requirements for now until you know that this requirement does not have any risk in the development or delivery in future. And there can be many different types of risk. For example, performance risk, security or safety risk, process risk. So process risk, the risk about process is, for example, this requirement will take much more time to develop. So it will slow the whole development process, and it will slow the delivery as well. There can be database risk, for example. So if you are using any non-standard data or non-standard database that is not easily achievable or doable, a requirement that involve such database risk should be mitigated using, for example, a simple database. It can be a CSV or even a text file, rather than using a database in the cloud or using NoSQL databases and so on. There can be, for example, schedule risk. So your planned process is being delayed due to this requirement. There can be stability risk. For example, your requirements is not very stable, so they may change frequently in future. So you need to take care either to make that requirements less stable, highly stable, or make it in your list of rejected requirements, so that you are not adding risk to your overall product or overall system. So there can be many different types of risk. Again, in the same fashion for requirements analysis, you should do this risk assessment for individual requirements and then make an overall judgment for each individual requirements. So here I have 8 risk. So each of those 8 risks should be assessed for each of the requirements, and then you can do a overall risk assessment for the requirements for each requirements basically. And based on this risk assessment, you can either include or exclude requirements in your release plan. And also similar to priority, so adding numerical values to as a risk could be not very straightforward and easy. So it's better to use some categorical values like high, medium, or low. And that's the final. We are now in the final part of the lecture. I know we are also running out of time, but let me quickly go through this part, like how we can describe requirements. And we should describe requirements in a way that it's not ambiguous, it's understandable, because most of the time requirements are described using natural language, and those natural language as a stakeholders or as part of the groups of stakeholders, since they're coming from different background, different experience, different knowledge, they vary a lot. So describing requirements using proper language is important, also for the developers and requirements analysts. The problems of using natural language is multifold. So that's why sometimes developers use different specification language rather than natural language, because natural language by default has this kind of problems, because sometimes they might include conditional clauses, so multiple dependencies between requirements or between phrases in the requirements statement. If you are using natural language, this is most of the time sloppy and inconsistent. And if you are using natural language, then people who are writing the requirements document, or people who are giving their requirements, they might assume by default that the other party or the people in the other side of the table have knowledge that they might not have. So describing requirements using natural language always have some challenges. And we can do three things to improve the requirements description, or how we can describe well requirements. The first thing is, of course, investing time and effort to write easy to read and understand text. The second thing is that do not assume by default that all the readers have the desired background and knowledge. So focus on being more explainable and more easy to understand, and also allow enough time to draft your requirements document and review it multiple times with the stakeholders. And what it will do, it will help you to have a requirements document, a good requirements document at the end, because time and effort is always and are two things that are not available for the developers and testers. So you should, as a requirements analyst or requirements engineer, should invest enough time and effort in writing the document. So there are many ways, as I mentioned, to write or specify requirements. Natural language is one of them, but there are design notations, there are graphical notations, there are mathematical notations, and also, and all of them has their own pros and cons. Some suit different audience than others. For example, people who don't have technical knowledge, they are more reliable, or they rely more on natural languages. But people who are, let's say, developers or testers or designers, they rely more on design description languages or graphical notations. But people who are, let's say, mathematician, or who likes mathematical notations, and mathematical notations are are less ambiguous and less prone to error than other languages, of course. So they might like mathematical specifications. But depending on the type of the notations, natural languages are least formal, whereas mathematical notations are most formal. And being least formal, natural languages are also most ambiguous, and mathematical notations are least ambiguous. But the issue here is that not everybody is expert in all the notations. So it's the role of the requirements engineers or analysts to start from the natural language sentences, and then go down as much as possible to avoid ambiguity as much as possible. There are some guidelines for describing requirements. For example, we should use a standard templates that will facilitate requirements understanding. We should also use our language in a simple and consistent manner and concisely, not to write large paragraphs or large documents. Then we should use diagrams where applicable, because diagrams makes things more clear. And if you have long text, if you use diagrams instead of long text, that basically breaks up the text and make the document easy to understand. And finally, if you have only natural language requirements, try to supplement it with other diagrams, like use case diagram or timing diagram or any other UML class diagrams and so on. And that will help to remove or minimize ambiguity in the requirements document. I think that was, yeah, this last part was quick, but do you have any question now on this first lecture that we can discuss quickly? I see no questions on Slack. Therefore, I assume nobody was posing any questions on Slack, but I saw many questions on YouTube. Someone said, is there any reading material for this first lecture? I think I mentioned already, I put some reading materials on my Moodle, and I also put the slides on my Moodle. So you can find some materials there. What I suggest, you go with the slides first, because slides are also self-explanatory, self-explained. If you have some issues, then we go back to the book. But most of your assignments will be from the slides. So it's an open book and some case studies that you will be working on based on the slides. And then, I mean, if you have further question, we might have, let me see. So we might have one tutoring session on Thursday, that is February 3rd. I will publish the time later. It will be on the same time, basically, of next week. So next Thursday, around this lecture time. So basically from 1:15 until 3, there will be some tutoring sessions. I will publish the slots later. So any other questions? If not, then have a nice afternoon and see you on Thursday. Bye-bye.